Thank you. Good afternoon. And I realize I'm the last speaker, so no difficult equations and things like that for you, okay? This is an overview of a combined project hitting on two topics that we've looked at today. One is concentrate on the physiological monitoring, the local area network to be able to get the physiological data, but also related to how do you know where that body is in 3 dimensions. And it's not so much trying to find a sensor inside your own body, it's actually locating an individual, whether that's a first responder, a firefighter, or so forth. The goal then of WPI system here, we've been focusing mainly on first responders, firefighters. We want to locate the person in 3 dimensions inside a building as they go about their environment. We need to be able to give a graphical display to the incident commander to improve their situational awareness so they know where everybody is inside the building. This work, unfortunately, started out as a very bad incident that happened in Worcester about 10 years ago when 6 firefighters lost their lives. They essentially got lost and disoriented inside the building. And ever since then, we've been trying to come up with a solution. This is part of the related project that Jalal mentioned this morning, the GLANSA project, which is trying to do the 3D location for first responders, and then the related phaser project. On the physiological side, we're trying to get heart rate, respiration rate, oxygen level, and so forth. And we're going about this in a slightly different way to some of the other technologies you've heard today. The idea is to use pulse oximetry. And most of you, if you've been to your doctor's office or unfortunately been in a hospital, they probably put the finger pulse oximeter device on your finger there to look at your oxygen saturation level. The problem with that, of course, for first responders, it would inhibit their movements out in the field. And we're aware of other shirt-based systems and so forth. But we've been looking at pulse oximetry device where we can actually do a forehead-mounted device. And So the idea is that inside this small package, you've got your optical sensor. Pulse oximetry works with a combination of visible and infrared light with then a photo detector, and then looking at the ratio of the received signals, you can work out your oxygen saturation level, and also then deduce other very important parameters too. So the SpO2 is the oxygen saturation level here, but you can also then derive from that same, is known as a PPG signal, you can derive from that same signal other parameters like heart rate, and then from there heart rate variability, arrhythmia, respiration rate too, even though that's a lot more harder to calculate. Perfusion index just shows you how well where you've located your sensor is on the site there. And we've included into this package also a 3-axis accelerometer, so you can also then get activity level. I think it was Dr. Cooper this morning that or someone else was mentioning about you need to know whether an individual is moving, especially a first responder, because if they stop moving, they're probably in trouble there. So the accelerometer can give you their posture. Are they upright? Are they crawling, upside down, and so forth? Activity level. And then with other sensors, you've got your skin temperature and so forth. The accelerometer can also help you with your motion artifact detection. A few speakers today have mentioned the problems with motion artifact, that anytime you put a sensor on your body, unfortunately, you're not going to be standing still while you take the measurements. You're probably going to be doing some vigorous activity, especially if it's first responder there. So how do you then get around those corrupted signals? And by using the accelerometer, you can maybe determine what activity you're doing and then clean up the rest of the signals. I am the computer engineer, if you like, trying to make this sensor as compact as possible to be able to wear this, to also be able to run. This runs for about a week's battery life, taking 80 hertz sample signals from the IR and red sensors. It's also got to do the RF transmission. This has got a 915 megahertz radio in there that then sends the information then to a USB based receiver. So I'm the computer engineer, trying to put all this technology into a small package. I look at envy with some of the other presentations we've heard today when, they're able to get something that will go inside the body there. So I'm jealous when I see how small they've managed to make some of their devices there. But I want to acknowledge some of the other professors in the biomedical engineering department, Professor Mendelsohn and also Professor Ki Chan, who are working on trying to get even more information out of this one PPG signal. By adding additional wavelengths to your LEDs, you can also do carbon monoxide detection, and also with some other calculations, you can try and get fluid volume loss. So if, again, you're in a battlefield situation and suddenly got quite a loss of blood there, you may be able to detect that, and also hydration levels rather too. The one thing we can't do, of course, is detect directly core body temperature, but one project, and I'll show you a slide in a moment, it was important they got the core body information too, so we had to do a receiver to, they swallowed this ingestible capsule. You can just maybe see at the bottom of the screen there, and that worked at 40 megahertz. So we had to pick up that signal and combine it with the rest there. So this is the project we've been working on to try and do physiological monitoring, trying to make it as practical as possible. Like I said, the fingers don't work for that. There's the earlobe, but the forehead is very good as regards accessing the necessary blood levels there. And the goal would be eventually to integrate this, maybe if it's a firefighter, into their air breathing apparatus or into a helmet, for example. The overall project that we've been concentrating on is there's your building, you've got the personnel inside the building, you're trying to do a 3D location and tracking there, so the firefighters, first responders, where transmitter signals are picked up outside the building, and then through rather complex multi-path mitigation and triangulation, you then determine their position. And then the other challenge, of course, is giving this information to the incident commander, where you'd ideally like to be able, this shows a floor plan view through the building where all the individuals are, and this is how we show our elevation, are they on the first floor, second floor, and so forth. The challenge is, Dr. Cooper mentioned this morning, how do you magically get these green, yellow, and red conditions to indicate, green is guys are all set, red, we're in big problem, we better get a rescue team in there to get them out, and how do you make that yellow that, okay, they're not in trouble, but they may go into trouble. That's a very, very difficult thing to do. In this case here, we just set a threshold for a heart rate going above a certain level to change these colors here, but we know that's totally artificial. This shows one of the workshops that we host each year on location tracking. Here's one of the firefighters, though, wearing our sensor, pulse oximeter sensor. This information was sent back with their position to the incident commander. And we've also done some work with the Air Force, Special Forces. They have a project called BALSM, Battlefield Automatic Life Status Monitor. And this is where we needed to add the core body temperature too. And over here is the combined receiver that picked up the information from the forehead pulse oximeter device and also the capsule that they had swallowed. That project was part of a project with Kinetic North America. And finally, I know that Jalal mentioned this this morning. I'd also like to give a plug for the workshop, which is, I believe, complementary to this in some way, that maybe got the physiological information or the local area network, but now where are the individuals? And so this workshop is focusing on location and tracking. Pleased to recognize, Jalal, that DHS is funding this project, this workshop this year. If anyone's interested, I've actually got some flyers for you. So just see me after today. And would like to finish by acknowledging, like I say, the other professors at WPI, especially in the BME department, the first responders we've worked with over the years, and also the different agencies that's funded. Thank you.